This is part 2 of 1-6. Howdy. Okay, you're good. Okay, we're going to talk about what happens if two people are working on the same job. If I can do the job in 2 hours and it takes Judea 3 hours to do the job, how long would it take us both if we worked together? Okay? So it's not a matter of, well, we'll just take 2 plus 3, add them together, and divide by 2 because they're both working. Well, that makes no sense. If I can do it myself in 2 hours, then how come both of us working together it would take 2.5 hours, right? Because that's the average of 2 and 3. And so there's a little bit more involved to it than that, except for the fact that Judea likes to sit around and talk, and if he works by himself, he does a good job. But if he's working with somebody, he likes to distract. Then maybe that's not true, or is it true? Not true. Okay. So if a job can be completed in 3 hours, that means that for every hour on the job, 1/3 of the job is complete. Does that make sense? In 1 hour, I do 1/3 of the job. In 2 hours, I've done 2/3 of the job. In 3 hours, I've done 3/3 of the job, and I'm done. So if a job can be completed in T units of time, then the rate of work, R is the rate, is equal to 1 divided by T. The amount of work completed, A, is found by multiplying the rate times time. Does that sound familiar? Rate times time, the distance formula, right? So instead of D equals RT, we're saying A equals RT because A represents the amount of work being done. Pretty straightforward. Let's look at a problem. One printer can do a job twice as fast as another. Working together, both printers can do the job in 2 hours. How long would it take each printer working alone to do the job? Any thoughts? What are we looking for? And go. Oh, we're looking for the question. Okay. So we have 2 printers. What would the rate of the fast printer be? Remember, rate is 1 over the amount of time it takes it to finish the job. That's definition. Rate is 1 over the amount of time it takes to finish the job. Do we know how long it's going to take the fast printer to finish the job? No, we don't. So what would we do in the case of an unknown? X, or any other variable. Okay, so the fast printer is going to do one job in X hours. I don't know how long, but it's going to take that printer X hours to complete the job. That's the fast printer. Well, there's also a slow printer. Rate of the slow printer. What do we know about the slow printer compared to the fast printer? Okay, it's going to take twice as long. So again, how long does it take the fast printer to finish the job? X. How long does it take the slow printer to finish the job? 2x. So the rate of the first printer, the rate of the fast printer is 1 over x. The rate of the slow printer would be 1 over 2x. Okay? I'm still completing one job in twice the time. The fast printer finishes one job in X amount of time. The slow printer, one job in twice that time. So how would you determine the speed of the two printers working at the same time? Add them together, right? We're both going to work together. We're going to work at a certain amount of time. Okay, the question says, how long would it take each printer working alone to do the job? How many jobs are we talking about doing? One job. So if we start with our A equals RT. A represents how many jobs we're doing. How many jobs are we doing? One. R represents the speed at which we're working. And because both printers are working at the same time, as you said, our rate is going to be adding the two printers together. 1 over x plus 1 over 2x. Working together, how long does it take these two printers to get the job done? What does it say? 2 hours. It tells us. So our time is 2. Guys, there's a lot going on here. Any questions about what just happened? No questions indicates perfection, and you can do it all by yourself just fine. Is that right? Y'all are experts at this already? Yes. Okay. Well, what does X represent again? The rate of the fast printer. Okay? So I've got an equation here. It's got one variable in it. That variable is X. We need to solve for X. What would be the first logical step to solve the equation? Distribute the 2. Okay. What is 2 times 1 over x? And if it helps you to write the 2 as a fraction so you can see it better, what do you get? 2 over x. Talk louder. What is 2 times 1 over 2x? And again, if you need to put the 2 over a 1, you can. 2 over 2x. Can you do anything with that? Can you cancel? Reduce those to 1s? So 1 over x. And guys, that's a problem just like we were doing yesterday. I have a rational equation. I call it a rational equation because my variable is in the denominator. How do you get rid of denominators? Multiply by the common denominator. What is our common denominator? X. I will multiply this entire equation by x. X times 1 is x equals, and what happens to 2 over x times x? X's cancel, leaving me with 2 plus 1 over x times x. X's cancel, leaving me with 1, so x equals, okay. And this right here, our final answer here, well, we're not done, but this answer, x equals 3, it's important that we did the very first step. We wrote down what x was. What does x represent? Okay, so the fast printer, if the fast printer was doing the job all by itself, how long would it take the fast printer? 3 hours. How long is it going to take the slow printer? Why 6? Because the slow printer speed was 2x. And that is the answer to the question. Okay. Any questions on this problem? Any thoughts, insights, ahas? Okay. Very good. Moving on. To solve a problem such as x minus the square root of 15 minus 2x equals 0, the variable is inside. The variable is a part of my radicand. Remember, the radicand is the part that's inside the radical. So my variable is a part of the radicand. In order to get x by itself, I must get rid of the radical. To get rid of the radical, what's the opposite of square root? Okay, yeah, the opposite of square root is square. So if I squared the square root of, say, 13, the square cancels the radical, leaving me with 13. Okay? What if I had the cubed root of negative 8? How do I get rid of a cube root? You cube it. Because a cube cancels a cube root, leaving me with negative 8. They're inverse operations. They cancel each other out. Okay? Here is the formal definition, and it's basically saying what I just talked about. If P and Q are algebraic expressions, I've got an algebraic expression on each side of the equal sign, then every solution of the equation P equals Q is also the solution to P to the nth equals Q to the nth. What they're saying is, if I've got an equation, I can raise both sides to the same power, correct? It's an equation. That's a legal action, okay? As with solving any equation, always check your proposed solution because we might end up with an extraneous solution. The steps to solving a radical equation. Step number 1, get a radical by itself. There may be more than one radical in an equation. You must isolate, get one radical by itself. If there's multiple radicals, which one do you get by itself? The answer is, I don't care. Just get one of them by itself. What's that? Okay. This is a radical. Let me make it bigger. Put it on the wrong side. Okay, here's the little picture here. Okay. This symbol right here is a radical. Okay. This number here is called the index. And this number here is called the radicand. Okay. Ask out loud, because you probably weren't the only one. Actually, he said he didn't know, so obviously you aren't the only one. Y'all good with that? Okay. Okay. So if we have multiple radicals, step number 1, isolate a radical. Number 2, raise both sides to the power of the index. Simplify. If you still have radicals, repeat step number 1. Do it over. Once you get done and you have no radicals left, just solve it. We're going to solve the equation x minus the square root of 15 minus 2x equals 0. Step number 1, isolate the radical. What would you like to do to get that radical by itself? Subtract x? I could do that. I would have done it differently, but you suggested this, so I'll do it this way. I have subtracted x from both sides. Is the radical by itself? Yes or no? No. What's with the radical? A negative sign. How do I get rid of the negative sign? Multiply or divide everything by negative 1, right? So all we're going to do is change the signs now? Okay, I'll change the signs. They both become positive. Change that one, change that one. There we go. Do I have a radical isolated? Yes. What is the index? What number did we not see that's right here? We call it a square root. So what number is right here? There's a 2 there, right? So to undo a square root, we will square both sides. I will square the left side and the right side. By squaring a square root, the radical cancels, leaving me with 15 minus 2x. Squaring x squared gives me x squared. Next step. First of all, what kind of an equation do I have now? A quadratic. So I started with a radical equation, and I now have a quadratic. And what's the first step to solving a quadratic equation? Set it equal to 0. Okay? Yeah, we put everything in order, descending powers. I want my quadratic term to be positive. So if it's okay with y'all, I will subtract 15 from both sides, and I will add 2x to both sides to take everything to my quadratic term. My left side is now 0. My right side is x squared minus 15 minus plus 2x. Let's put it in order. Plus 2x minus 15. Okay. I will now factor this. And folks, if you're still struggling with factoring, you need to come in for tutoring. Okay? I don't want to spend time in this lesson talking about how this factors. This will factor into x plus 5 times x minus 3, because 5 times negative 3 is negative 15. 5 plus negative 3 is 2. Using the zero factor property, x is either negative 5 or x is 3. And I got those answers by setting both of those factors to 0 and simplifying. So my proposed solution is x equals the set of numbers containing negative 5 and 3. What's my next step? Plug them into the original problem to see if this is in fact true. Okay? Let's try negative 5. A little question mark there. Well, I'm going to take my original equation, and everywhere I have an x, I'm going to replace it with a -5. So I have -5 minus square root of 15 minus 2 times -5 equals 0. That gives me -5 minus the square root. 15 minus 2 times -5 is 25 equals 0. -5 minus 5 equals 0. Is this true or false? Yeah. -10 equals 0. That's not true. So I now know that -5, though it was a proposed solution, is not in fact a solution because it does not satisfy the original equation. Let's try x equals 3. Same thing. The original problem, I'm going to replace all the x's with 3. So 3 minus the square root of 15 minus 2 times 3, is this going to equal 0? Doing the math, I have 3 minus the square root of 9 equals 0. 3 minus 3 equals 0. How are we feeling about this? Feeling good? That checks. So when we solved this, all of our math was right, all of our algebra was good. We did end up with an extraneous solution. -5 did not work. Final answer. Our solution is x equals the set of numbers containing 3. Questions or comments or anything about this problem? Is this better or worse than yesterday? Better. Worse for Trayton because he wasn't even here. Okay. All right, here's another problem. Square root of 2x plus 3 minus square root of x plus 1 equals 1. Step number 1, isolate a radical. We have 2 of them. You must isolate one. Which one? Does not matter. Good. What would be a logical step to get one of the radicals by itself? Add the radical of x plus 1. Okay. I have square root 2x plus 3 equals the square root of x plus 1 plus 1. Is this one completely by itself? Yeah. So it doesn't matter which one it is, you just have to get one of them by itself. This is going to be ugly. I'm taking square roots, so to get rid of the square root, we will square both sides. Left side, squaring the square root, cancels the radical, leaving me with 2x plus 3. And what about that right side? No, not that easy. It's a binomial squared. See, the square root of x plus 1 is one thing. 1 is one thing. That's a binomial by definition. So what do we have to do? FOIL. And guys, if it helps, rewrite it. Get rid of that square and actually rewrite the square root of x plus 1 plus 1. If that helps you see the FOIL process or the double distribution process, it took me 3.5 seconds to write that. Okay? Let's FOIL it. First times first. Square root of x plus 1 times the square root of x plus 1. X plus 1. Okay? Outside times outside. Square root of x plus 1 times 1 is just the square root of x plus 1. Inside times inside. 1 times the square root of x plus 1 is just the square root of x plus 1. And last times last, hopefully y'all can get that one. All over it. Y'all good with that? Okay. Let's combine like terms. Left side looks good. Which numbers? Okay. Okay. Combining like terms, on the left, on the right side, I've got an x. I have 2 of these square root of x plus 1s. So plus 2 square root of x plus 1. And then I have these 2 constants here, so plus 2. How are we doing? Okay. So step number 1, isolate a radical. Step number 2, square both sides and simplify. We're done. The next thing, do we still have radicals? Go back to step 1. Step 1, isolate the radical. Okay, so I need to get this guy right here all by himself. What would you like to do? Quitting's not an option. Yeah, but you want to move that over, or do you want to get rid of the stuff that's with it? So you'd rather radical be on the right side, on the left side? Okay, I'll do that. So subtract this guy from both sides. I now have negative 2 square root x plus 1 plus 2x plus 3 equals x plus 2. I did what you wanted to do. How did that help me? Okay, I will subtract 2x from both sides. I will subtract 3 from both sides. And that leaves me negative 2 square root of x plus 1 equals x minus 2x is negative x. 2 minus 3 is minus 1. Is everybody okay? I went ahead, moved the slide a little bit. Was anybody writing down stuff that was up there? We're good? Okay. Is the radical by itself? No. What do I need to do now? Not 2, but negative 2. I now have the square root of x plus 1 equals x over 2 plus 1/2. is the radical by itself? Yes. What do I need to do to both sides to get rid of that radical? Square both sides. Again, left side is pretty simple. Squaring a square root cancels, leaving me with x plus 1. But what about the right side? Do what? Just take it. Just take the 0. We'll FOIL again, right? And again, if it's beneficial to you, rewrite the x halves plus 1/2. First times first. X over 2 times x over 2. Multiply straight across. What do you get? X squared over 4. Outside times outside. X over 2 times 1/2. What do you get? X over 4. Inside times inside. It's the same thing, isn't it? Plus x over 4. Last times last. 1/2 times 1/2 is 1/4. Now what? Simplify it? I could. Let me kind of talk y'all through what's going to happen here. If I added x over 4 and x over 4, that would give me 2x over 4, which is x over 2, right? So I've added them together, and then I reduced them. How many denominators do you see? 1. What is that denominator? 4. Can I multiply everything by 4 and get rid of the fractions? Yes. So though it might be a little weird that we didn't simplify before that, that's okay. 4x plus 4 equals x squared plus x plus x plus 1. Combine like terms. 4x plus 4 equals x squared plus 2x plus 1. Quadratic. Bring everything over to the x squared. Where you lost? Okay. I will subtract 4x from both sides. I will subtract 4 from both sides. Now the left side is 0 equals x squared minus 2x minus 3. And that factors easily. X minus 3, x plus 1. Negative 3 times 1 gives us negative 3. Negative 3 plus 1 gives me negative 2. So either x equals 3 or x equals negative 1. So my proposed solution is, go ahead. Because x minus 3 equals 0. Get x by itself. What do? X plus 1 equals 0. So x equals -1. Okay. So my proposed solution is x equals a set of numbers containing -1 and 3. Now that I have two answers, what do? Plug them into the original problem. And I am not going to do that just for sake of time. I could plug them both in. I'm going to tell you they do both work. Okay? But don't assume they both work. You always need to check. Am I assuming too much stating that y'all could probably be successful plugging those in? Is that a stretch? All right. Okay. Questions on that? Okay. All right, one more problem. This one's not bad. This one's actually easier than the last one. Okay? There was a typo. It was a plus, which was wrong. So I wrote over it with a white pen and then put the negative in. So it's supposed to be a negative. All right. I have two radicals. They happen to be cube roots. I don't care. The process is the same. Step number 1, isolate a radical. Well, when I isolate the first radical by adding the cube root of x to both sides, doesn't that actually end up isolating both of them? Okay. How do you undo a cube root? You cube it. Okay. Again, whatever the index is, you raise it to that power. And by cubing a cube root, you will cancel the radicals. I now have 4x squared minus 4x plus 1 equals x. Okay. Subtract x from both sides. 4x squared minus 5x plus 1 equals 0. Now what? Factor it. A is not 1, so how do you want to factor it? Okay. Snowflake it. AC is 4. B is -5. Top left, top right, 4x. What two numbers multiply together to get 4? But when you add them together, you get -5. -1 times -4 is +4. -1 plus -4 is -5. Does either one reduce? The second one reduces to x over -1. So this factors into 4x minus 1 times x minus 1 equals 0. Using the zero factor property, I will set both of those equal to 0 and solve. So x equals 1/4 or x equals 1. My proposed solution, x is equal to a set of numbers containing 1/4 and 1. I've got two answers. What do I do with the two answers? Plug them into the original problem. They both work. Okay? And so because they both work, my proposed solution actually becomes my actual solution. And we will continue tomorrow.